Welcome to homework.
Problem 45 gives us a graph of the relative abundance of fern spores and angiosperm pollen grains throughout the Cretaceous and early Paleogene time periods. And it shows a distinct drop in the percent relative abundance in between these two periods during this boundary, and then a sharp rise in the number of fern spores, but not a sharp increase in the number of angiosperm pollen grains. It asks us to propose reasons for the observed increase in fern spores following this mass extinction that occurs here. And it gives us 4 options to choose from. So let's go through all of them. Part A, ferns are considered early colonizers. They grow fast on poor soil and reproduce rapidly. This is true. So early colonizers would need to grow fast on poor soil because after a mass extinction effect, it's not likely that the soil is going to be very viable. Also says mass extinction gives the opportunity for the surviving species to expand and radiate to occupy vacated niches. This is also true in that after a mass extinction, you're going to have many niches that no longer have predators or really anything, and so specific species can have this opportunity in order to take up those niches that they might not have been able to gain traction in previously. So A is looking like a pretty good option. Option B is ferns having a selective advantage of being early colonizers, grew fast on poor soil and reproduced rapidly, thus replaced angiosperms in the landscape. And by the graph, you can identify that that is not true because both ferns and angiosperm pollen grains were completely depleted or nearly depleted during this mass extinction. And so it's not necessarily that the ferns replaced angiosperms, it's that they were able to increase in population size, whereas the angiosperm pollen grains were not. So B is not a viable option. C, ferns are considered early colonizers as they grow fast on poor soil and reproduce rapidly. Yes, we've discussed this from part A. And also mass extinctions gave an opportunity for new species to radiate and thereby occupying vacated niches. So this specific part of C that says new species to radiate, it's not necessarily that there's new species to radiate, but the fact that you have these mostly depleted species that were able to then gain traction in a new environment. For that reason, C is not a viable option. Last one, part D, most of the fern varieties became extinct and only a single species survived. Therefore, the remaining fern spores had many vacated niches to occupy, which led to an increase in fern numbers. This could be true, although it's more likely that there's a variety of fern variants that were able to survive. It could be true, it could also not be true, and so it's not a reasonable answer when we have A, which is a much more reasonable answer for this increase in fern spores. So for this, we're going to go with part A.